Hello everyone, welcome back to your channel Physics with Oliver. Today we will discuss another problem from ray optics. Before starting the problem, I will request you to press the bell icon and subscribe the channel. Thank you everyone. Now I am starting the problem. At first read the problem. A bulb is present at a depth of 2√7 meter in water. The refractive index of water is given and a floating opaque disc is placed over the bulb so that the bulb is not visible from the surface. What is the minimum diameter of the disc? Before starting the problem, I will discuss some theory portion so that it will be easy for you to do the problem. Suppose this is a medium, this is the denser medium and this is the rarer medium, okay? And this is the source of the light. Light is going this way and then this will refract. We all know if the light is going from denser to rarer medium, the light will bend away from the normal, right? So we have drawn this, and at some particular angle theta, we will see at a particular incident angle theta, that is known as theta c, we will see the refracted ray will be like this. That means the angle of refraction is 90 degree. This particular angle theta is known as the critical angle. If the value of the incident angle is greater than theta, in this last ray we can see the value of theta, this is greater than theta c, we can see the ray will not get refracted, rather it will reflect. Okay, it will reflect to the previous medium, to the denser medium. This phenomena is known as total internal reflection. Okay, right? For this case, for the last case, which I have drawn using green color ink, for the last case, the ray will not go out to the rarer medium. Okay, it will come back to the denser medium again. Right? Okay, now we will start discussing the problem. This concept will help us. Okay. So now we can see the incident rays are going like this to this disk. Okay, if this angle, I am erasing this so that you can understand this clearly. Wait, if this particular angle I have drawn is the critical angle, we know this is the water, so this is the denser medium and this is the rarer medium. If this angle is equal to the critical angle, then when the ray come in this way, this angle should be theta, this theta should be greater than theta c. So this ray, this is the second ray, this ray will get reflected back to the medium, right? Okay, if this is the angle theta c, critical angle, then this ray will get reflected back to the previous medium, right? So if this situation happen, then no ray from the bulb will go out from the water medium to the rarer medium or to the air medium. So the bulb will not be seen from the outside medium, right? Now I will show you the different cases also so that it will be clear to you what is happening here. Suppose this is the disk and this angle is less than theta c. This angle theta is less than the critical angle. Then what will happen? Then if the ray is going and this angle is less than critical angle, then the ray will refract to the rarer medium, right? The ray will refract to the rarer medium, and from this medium, if we put our eye from this medium, we can see the bulb here. Okay, right? And now the third case, if the theta is greater than theta c, we will discuss the third case. This is the disk and this is the angle theta. If theta is greater than theta c, so for each and every ray, for this ray and for this ray, all the incident angles are greater than the critical angle. For all this ray, total internal reflection will happen. So no ray will come to the rarer medium. So from the rarer medium, we cannot see the bulb. So this case and this case is allowed here. Sorry, this case and this case. These two cases are allowed here, right? This is not asked in our question because for this second case, the bulb can be seen from the rarer medium. Okay, but it is asked that what is the minimum diameter of the disc. For this first case, the diameter will be minimum. The value we will get r, that will be the minimum value. And if we increase the diameter of the disc, then we will get this third case. Okay, so now we will discuss this case 1. Why we are taking this case 1, I have already discussed, right? So now I am discussing the first case, that is the R minimum we have to calculate. So from here we can write that sine theta c is equals to the perpendicular, that is R, divided by hypotenuse, that is R square plus H square. We all know the formula that sine theta c is equals to 1 by mu, right? The value of the mu is given here. So we will write this 1 by mu is equals to r divided by root over r square plus h square. And from here by calculating we will get r square divided by r square plus h square is equals to 1 by mu square. So we will get r square plus h square by r square is equals to mu square, that is 1 plus h square by r square is equals to mu square. So h square by r square is equals to mu square minus 1, right? So r square is equals to h square divided by mu square minus 1. We know h is equals to 2 root over 7. So h is equals to 4 into 7, that is 28 meter, and mu is equals to 1.33, right? Now we will put the value. This 1.33 means 4 by 3 square minus 1. This is root, right? So this is root over 28 divided by 16. This is 9. This should be 9. Now I'm deleting this so that I can get space. Root over 28. This will be 7, right? So root over 28 into 9 by 7. This will be 4. This will be 36. Be 6. So our minimum will be 6. So we have to calculate the minimum diameter. So the minimum diameter should be 12 meter. Okay, the answer will be 12 meter. If the diameter of the disc is greater than 12 meter, then no problem. All the rays will come back to the water medium after total internal reflection. If the diameter is less than 12 meter, then some of the rays for whom the incident angle is less than the critical angle, the ray will refract to the air medium and we can see the bulb. Okay, so the minimum diameter is 12 meter. I hope you can understand this. If you have any problem, you can ask in the comment section or you can email me. Thank you everyone. Please subscribe the channel.